Hello guys, welcome to my YouTube channel. Today we are here to solve Leetcode problem of the day, and today is 6 October 2024, and the problem is sentence similarity, and it is the third version of sentence similarity. So there will be two more problem, sentence similarity 1 and 2. You can also prefer to solve that, but it is not too much hard and not too much dependent with the in the previous two version of this sentence similarity, so you do not have to worry about it. So let's begin with reading the sentence. Basically, you are given the two sentence 1 and sentence 2, each depending sentence composed of words. A sentence is a list of is very similar sentences, just like in English language. So there will be no leading or trailing white spaces, and each word will be separated by a single white space. Each word consists of, you have to note here that each word may consist of upper or lower case English characters. So you have to find the same. You can make these two sentence similar. And what is the definition to make the two sentences similar? And the definition is, two sentences are considered similar if it is possible to insert, you have to note here that a single an arbitrary sentence, possibly empty inside, possibly empty, possibly empty, saying means that it might be possible that both given sentences is already similar, so you do not have to insert anything. So you also have to keep in mind, as well as you have to also keep in mind that that only single insertion of a sentence, an arbitrary single sentence, you can only insert inside one of the sentences so that the two sentences became equal. Note that in such a sentence must be separated. And yeah, this is also a note point. I will explain in the third example that insertion must be something like you can't just concatenate a single word, a single character or set of character. You have to insert the words separated with white spaces, something like that. So these are the examples that, like, sentence one is given hello Jan, and hello, my name is Jan, in the sentence two. So what you can do is that okay, hello and hello Jan, this prefix and this prefix are similar, and this suffix and this suffix are similar. So what you can do, you can just take it and just put in between those two, so that s1 and s2 will be similar. So in the example 2, I mean, yeah, this note point are actually explaining this statement. S1 is given in the frog pool, and frogs are pool are not similar, because what you have to do, you have to take it something like this and you have to put it here. But this note point is saying the insertion must be separated from existing word by spaces, that you cannot concatenate a character or set of character in the existing word. You have to put word which will be separated from existing word by wide spaces. This this insertion is not allowed, so the answer will be false. And what is the return statement is given, your given sentence 1 and 2, and return true if sentence 1 and sentence 2 are similar, and false otherwise. So say the example number 1. So my name is Hallie, and here is my Hallie. So what you can do is, you can put these two sentences and you can put it in between my Hallie, so these two became similar, so the output is true. Similarly, if you can see in the example 2, so you can't make by a single insertion. You can convert sentence 1 to sentence 2 by single insertion. You have to insert two sentences. Let me show you how. You have to take this a lot, and you have to put as a prefix here, and then again you have to take it this word and you have to put as a suffix, and then these two sentences will be similar. But there is the constraint that you are only allowed to insert a single sentence, arbitrary sentence, so the output is, so that's why the output is false. So in the example third, you can see that you can both sentence 1 is eating right now, and then sentence 2 is eating. So what we can do is we can just take it these sentence and we can put as a suffix in the sentence 2, so that these two sentences will become, you know, similar. So that's why the output is true. So this is all about the statement that is given here for sentence similarity third problem. So let's try to think that how will be our approach and how we will come with a better solution so that we can solve it efficiently. So let's start to analyze this. Let's start to analyze it now. Okay, so I am just taking a character as a word, assuming that a character will represent a word. So if you have given like something that the four cases, there will be the true cases and false otherwise. So I will explain each of these cases and how you will have to approach it. So in example 1, if for sentence is given something a b separated by white spaces, a b and c and d, these are the these are the four words, and then you are given something like a and b and nothing else. So I am just making a sign that these are not available, so these are only two available. So these, so in this case the answer will be true because these two are character similar. So if you will copy these character here, so these both sentence s, if this is the s1 and this is the s2, then s1 s2 became similar. In example 2, let's say if sentence 1 is given a b c d and second is given c and d only, so how you can make, so okay, then these two are similar. So what we can do, we can just copy it here, so both the sentence will become similar. And in example third, what there will be like something a b c and d, and there will be like a and given is d only. So what we can, these are similar, so okay, all right, what we can do, we can copy this sentence and paste it here. So these two sentence will become a b c d and a b c d, so the both will be similar. And example 4, if you already have given both or is you have, if you have already given this similar sentences like a and b and c and d, and also the a b c d, so you just not, you do not need to check anything, you can return these are only, so you do not have to insert anything, you can only return true. So these are the true cases. Okay, what will be the false cases, like there will be the false cases like as we have also seen in the statement of the problem in the problem statement, that a, if like you have c and d, if you have only given this a single one, so you have to copy it here and you have to copy it here, but only a single insertion is allowed, so the output will be false. Or something a b c d are given, and like you have given a and let's suppose c is given and d is given, so you will check that a okay, these two are these two are similar, okay, and d are similar, but here here is B and here is C. So uncommon words are here, so you have to return it false. These are all the cases that you need to check. So we will not check the false cases. Other in the else statement we will return false. We will only check the correct, all these four correct cases. So how we will approach? We will take a pointer here, and we will take a pointer as well as here. For the here, what we should check the, because the prefix, you can see that prefix suffix, sorry, prefixes is similar, as you can see. So at the beginning we will check the prefix. So okay, these are two are similar, okay, these two are again similar. So pointer will goes to the next one, okay, then those two similar, okay, then again when the pointer will goes to here, and it will reach to the end of this. So in this case, whenever when the pointer hit to the end of the list in either of the sentence, so we will return true. In the similar case, and for the suffix, there will be a pointer here and there will be a pointer here, so these are true, so the pointer will goes to here and goes to here, and you hit the index -1 for this one, so this will also be true. So in this case, what we will do during the prefix iteration and suffix iteration, what we will do, we will take an extra variable, like suppose these, and this will be a loop, this will be a loop, and in this two loop, what we will do, we will check, okay, all right, the pointer is here for in case of prefix matching, so a is matching, okay, then we will see that either the next will be matching or not. Say a and d are here, so these are not matching, so our in case of prefix we will make a variable called left, and this will, in case of this one, left will be print to 0, and left will be here, and then in case of suffix matching, we will do, there will be a pointer here and there will be a pointer, so these two are matching, okay, we will make a pointer right, and it will be in case of 0 1 2 3, it will represent to index 3. So because the next one is a and c, these two are not matching, so we will stop it here, okay. But if you will see for the indexing here, there is only two elements, this is 0 and this is 1. So whenever, and here just keep in mind for this one, and I will explain it how these two indexes left and right will help to recognize that this is the case where you have to return true. The middle sentence have to copy it here, and let's try to explain me first this one. So if the pointer will be a and the prefix will be matching, so left pointer will also will be here, then it will goes to, because two are matching, so this and this, and the left pointer, because in the loop where I will match the prefix, so the left pointer will be here. So in case of suffix matching, so D and D are matching, CC matching, BB matching, A matching, so right pointer will goes to here. So you can see that left pointer goes here and right pointer is here. So and as I have said that, okay, the left pointer is here. In case of example third, left pointer is here and right pointer is here, and you can see that right pointer goes to here and the left pointer is here at the end and at the -1 index. So from these two we will make a, you know, we will make a conclusion that if whenever that right minus left is less than or equal to 1, if this will be the case for these two cases, for these cases we will return true, otherwise we will have to return false. You can see in the example number here, so our left pointer will be here because these are the only the matches, and then next character will not match. So left pointer will be here. So, and in this example, right pointer will stop here because these are only the suffix that are matching. So right pointer will be here. So you can see that the differences, because these are the smallest sentence. So you can say 0 1 2. In this case the difference is 2. What this is that instead of instead of prefix and suffix matching, there are few more characters that is not matching to each other. That's why the middle insertion will not be possible. So that's why I have made this conclusion that whenever the right minus left is less than or equal to 1, the output will be true, otherwise false. So this is all about how we will approach with the to this problem, and this is our this will be our solution, and let's try to begin code now. So as I mentioned that, okay, there is one more catch that I will convert these. I will These are the sentence 1 and sentence 2. I will split each of them separated by comma, so I will get a list of string, and white spaces will be removed. So suppose the name is s1, then sentence 1 is split with white spaces. So this will return me the list of words. So similarly for the s2, okay, all right. You know that at the end you have to, no, you do not need to. We will check it. So I'll make a variable left, and it will point to, and I will make a point. So make two variable, two more variable, and one equal to s1 dot length. How many words are there in the sentence 1, and how many words are there in sentence 2? Okay, right will be dot, right will be maximum now. So I will iterate from 0. I math dot maximum of n1 comma n2. So as I have said that if I equal to n1 or I equal to n2, sorry, n2, you have to return true. So let me put it here. So this is for the, let me write, for the prefix matching. This is for the prefix matching. Okay. I will also that if s1 dot equal s2, so we have to return. I will make an extra variable found boolean found equal to true, break. if not equal to, if these two character that why I make this an extra variable, because let me show you that if these are the cases that if this one this will match, this will match, this two word will match, this two word will match, so you will hit at the end of each word. So in this case you can see that both are already similar, so in this case you do not have to do anything. So so that's why this will say that you didn't hit at the end of each word, so you have to return. So if you found, then you have to return this, saying that both are already similar. Okay. Now then if for the now now for suffix matching. Okay, this will be same, so I'm just copying here. Okay, I will start from here and let me show you that there is a, you know, you have to make a variable I1 that will represent that I. So it was very easy to, from start from index 0 for both the cases. So I to in case of matching, prefix matching, it is very similar, it is very easy to start with the index 0, but to start suffix matching, because they both might have different length, so you cannot start with a specific index, so you have to explicitly, find end index of each character to check the similarity. So I am just n1 minus 1 minus I. This will represent the endpoint of the first, and then n2 minus 1 minus I. This will be the endpoint. And if I will say if I1 is less than 0 or I2 is less than 0, this is that you have reached at the end of one, in the at the end of each, at the end of word of a sentence. So end means that the index minus 1, so in this case you have to return true, because the right word already matching with in both the sentences, so you have to return true. So let me show you that this will represent to this one, for example 2, then cd and similar, these two are similar, then it will hit to the index 1. So because the sentence 2 is smaller, so that's why it will hit to index minus 1. So you, in this case you will copy it here and answer will be true, so that's why I'm returning true here. So okay, mm, this will be I1 and this will be okay. If these two are not similar, you have to return false, because we have, if both are exactly same, so we have already checked it here, so you do not need to check again that if you are moving from right to, from last index to the beginning, to the first index. So if all are similar, we have already you know checked in these cases. So and we have also made the variable, so in this case I will left for this will say that you got a match, and that's why the left is going to the first index, 0 index. So minus left will be minus 1 when there will be a single match, so left will increase to 0, and that's, if there is two match, then left will 2, and when we hit, you know, hit at the end of any of the sentences, you will return true, and if you got any non-matching word, so in this case you will break the loop. And so here for the suffix matching, similarly for the suffix matching, if you hit that either of already reach it the index -1, so you will have to return true, and if both are not similar, so we will break that. So this, and I will, as I have said, that right minus will be there, and this right will be full x, and then right will be uh, minimum of. Why minimum of? Because you know, you have to compare for the minimum length string, not for the maximum length string. As you can see here that for uh, here a b c d, in the third example you can see that left pointer will be here and right pointer will be here. And so for the smaller index we are checking for the, as you can also see here that for the smaller index we are checking that length is 2, and these are the bigger sentence and these are the smaller sentence. Similarly, these are the bigger state sentence and these are the smaller sentence, only two word are there. So that's why I am starting from index. So in this case 0 and 1, only the two length sentence. So right will start from the minimum of n1 and n2. So as I have mentioned that at the end I will check if right minus left is less than or equal to 1. No, so what we can do, we can directly write it that return. So this is all about the solution. Let me try to execute the test cases now. There is an error. Okay, I didn't put the semicolon here. I also forgot the semicolon here. Let me run it now. Okay, so then sentence 1 dot sen, sorry, there is a spelling. Sentence 1, okay. So out of bound index, let me see that where it is. I1 and I2. Hmm, S1 and 1, okay. I didn't hit this. Sorry. No, I have to increase it now. So what is sorry, I have written 2 here. I have to read it I2. This might be the problem. Again, index -1. Why is that? Sorry, this will be I1 and I2. So these are the test cases. Let me try to submit it now. So you can see that our code have been submitted now, and it beats 96.40% of the people that has been submitted in Java. And in memory constraint, you can check that our solution have taken 41.54 MB, and beats 67.06% of the people who have submitted in Java. So this is all about the problem. So if you have any query or if you have any suggestion, you can ping me below in the comment box. I will reply you whenever I will get the time. So please subscribe my channel if you feel it is helpful for you. You can also share it with your friends who are excited and you are very eager to in competitive programming as well as DSA. So please subscribe my channel and stay healthy and keep growing. Thank you. Have a nice day.